This is our fourth video on convective turbulence. And in this video, we're going to look for ways to identify convective turbulence by looking for thermal patterns. One of the most obvious thermal patterns is cumulus clouds. If you see cumulus clouds, then you've got thermals. And in this picture taken from our research jet, you can see that we're flying on top of the cumulus clouds, and we've got a nice smooth ride. We're sitting here at about 10,000 feet. But below the tops of the cumulus, you'll be punching through the cumulus and you'll be getting a rough ride, as well as below the cloud bases where there's plenty of thermals causing lots of convective turbulence. Of course, each little cumulus cloud has a thermal with it, so the more cumulus, the more thermals. Then also from satellite, you can see thermals by looking for an open cellular convection pattern. And what that means is that it looks like over in this particular picture, the states of Virginia and North Carolina, maybe even up the Delmar Peninsula and into New Jersey, you can see little dotted white little dots which indicate cumulus clouds. And that happens usually behind a cold front in the cold air with warm ground. You'll get thermals that rise and cover a large region. Another pattern that you can identify is cloud streets. Cloud streets occur when thermals rise and they advect downwind with the wind. The wind blows them downwind. So in other words, the picture you're looking at here is from the space shuttle. You're looking at, I think this is the Pacific Ocean, and there are islands in the ocean, and the islands heat up more than the surrounding water, so they produce thermals. Those thermals rise and are carried downwind, and you can see downwind of each island you've got these cumulus clouds. So those are an indication of convective turbulence in the lowest layers of the atmosphere, downwind of the mountains or downwind of the islands. So how do you fly this kind of turbulence? How do you avoid convective turbulence? And to do that, usually you fly early in the morning. Early in the morning, the ground is cool and you don't have thermals. As the day progresses, thermals will rise higher and higher through the atmosphere until they're at their peak, usually in the mid-afternoon. Also, if you climb above the cumulus clouds, you get a smooth ride. In the cumulus clouds and below the cumulus clouds, you'll get a rougher ride. That will be your layer of convective turbulence, what we call the mixed layer. Remember that on top of the layer of convective turbulence, you usually find an inversion, and that capping inversion prevents the cumulus and the thermals from rising any higher. So the capping inversion usually is at the top of cumulus clouds. If there are no clouds, then you have to look for the haze layer. And the haze layer indicates the mixing layer. In other words, above the haze layer, you'll see clear sky, and you can actually see almost a line in the sky. In this picture off the wingtip of the Citation, you can see clear air above and kind of hazy air down below. We're flying on top of that hazy air in the smooth, free air of the atmosphere, the clear air of the atmosphere. Down below that line, that is your mixed layer. And what causes that line is the capping temperature inversion. It prevents air from down below mixing with the air above. So that's why it traps all the pollution and all the moisture in the lowest layers of the atmosphere. So when you see that haze layer, that indicates a layer of convective turbulence. Another thing to be mindful of is as you descend from higher altitudes into that haze layer or into the layer of convective turbulence, you're going to get a rough ride. So you probably want to slow the airplane down to below its maneuvering speed. That is the end of this video. In the fifth video, we'll talk about flight planning.